Welcome back, class. Today is going to be about solving systems using matrices, more specifically what we would call the Cramer's rule. Before we can actually get into that specific method, we have to talk about a determinant. And so just as a quick reminder, when we talked about dimensions, remember that if a matrix has the same number of rows and the same number of columns, that's called a square matrix. And so that could mean you have a 2 by 2, 3 by 3, 4 by 4, and so on. We're going to be mainly focusing on 2 by 2s and 3 by 3s. Now, in order to eventually use Cramer's rule, we have to calculate what's called the determinant. And the determinant is just one number that's found, and we have this particular method that I'm going to show you here in a second, and it basically just helps us determine if a system of equations has one unique solution or if it's going to have infinitely or no solution. It's also going to be helpful if you're asked to find the area of a triangle on a grid, on a coordinate grid. Rather than having to find the length of the base and the height, we can use our points and our matrices to calculate that number. So we're just going to go ahead and go into an example. We're going to start off with 2 by 2s and then work up to 3 by 3s. So it says here, find the determinant. When we label the determinant, normally you're going to have these bars that look kind of like absolute value, but remember they're not absolute value symbols, so be very careful. And really all we're going to be doing is multiplying diagonals. That's going to be our main concept. So we're going to multiply the first diagonal from top to bottom. And when I multiply those together, we get negative 48. And then we're going to do the same thing, but going the other direction, multiply from bottom to top, and that gets us negative 70. Once you've done that in a 2 by 2, then what you're going to be doing is taking always the bottom minus the top. So we're going to have negative 48 minus negative 70. And notice I put parentheses around that second negative just so you don't get your negatives confused. So if we go ahead and make those two negatives a positive, then we have negative 48 plus 70, which is 22. So our determinant is 22, and we're done. So with a 2 by 2, it's really quick and really easy. Multiply one diagonal and then multiply the other, and then subtract from bottom to top. The one mistake people tend to make is just being careful with the signs, and just make sure you're always subtracting bottom minus top to get the right order. So I'd encourage you to go ahead and try this one here at the bottom, multiplying the first diagonal, multiplying the second diagonal, and then subtracting and seeing what you get. You should have gotten negative 24 if you calculated correctly, because the first diagonal is 0, second diagonal is 24, and you take 0 minus 24, that's negative 24. Now we're going to use a similar concept with 3 by 3s. There's just going to be one extra major step, or maybe two extra steps that you would need to complete. So in a 2 by 2, there's only two diagonals you have to worry about. In a 3 by 3, we now have more diagonals, and so we have to work with multiple diagonals and multiple numbers. So what we're going to always do first in a 3 by 3 is to take the first two columns, so column 1 and column 2, and we're going to rewrite them at the end. And this is going to make our diagonals easier to work with. So there's the first column and then the second column, and you always want to put the first column first. And then we're just going to start working with our diagonals. So we're going to start off by working with the top, so going top down, so 4, 2, and 9. And then negative 8, 6, and negative 4, and then 3, negative 3, and 5. So we're going to do all three of those diagonals and then add those numbers together to get the one number at the bottom. So 4 times 2 is 8, 8 times 9 is 72. Then we can multiply negative 8 times 6 times negative 4, that gives us positive 192. Okay. And then 3 times negative 3 is negative 9. Negative 9 times 5 is negative 45. So we're multiplying the diagonals, just like we did before, and then we're going to add these numbers together. So 72 plus 192 minus 45 gets us to 19. So there's the number at the bottom that we're going to be working with at the end. And then we're going to go back through, same concept, but we're going to go from bottom to top. So bottom left, up, and then make sure we go all the way to the end. Okay, and you can only do this when you have 3 numbers in a diagonal. You don't want to do the diagonals that only have 2 numbers in them. So it always has to have 3 because it's a 3 by 3. So we multiply -4 times 2 is -8. -8 times 3 is -24. 5 times 6 is 30. 30 times 4 is 120. And then lastly, 9 times -3 is -27 times -8 is positive 216. So combine those together and you get 312. And now it's just like the last example with the 2 by 2. You always take the bottom minus the top. So 219 minus 312 is going to get us -93. And you always want to double check your multiplication, double check your addition, but you should get one number at the end, and that is your determinant. I would encourage you to try this example down here. Remember, you need to rewrite the columns 1 and then rewrite column 2 at the end, and then just start doing your diagonals. If you have any questions about how to find the determinant, please let me know.